Welcome to Chapter 7, Laws of Exponents, a thrilling exploration of mathematical powers. We'll begin by delving into the key ideas and fascinating examples that will shed light on these essential principles. Exponents are a mathematical notation used to represent repeated multiplication of a number by itself. When we see an expression like a circumflex nine ammens, a is referred to as the base and n is the exponent or power. This tells us that we need to multiply the base a by itself n times. For instance, in the expression 2 cubed slash, the base is 2 and the exponent is 3. This means we multiply 2 by itself 3 times, 2 times 2 times 2, which equals 8. Thus, 2 cubed equals sign 8 slash. In summary, exponents provide a way to represent repeated multiplication in a concise and efficient manner. They are fundamental in various mathematical operations and are essential for understanding algebra, calculus, and many other areas of mathematics. If you have any more questions or need further explanation on exponents, feel free to ask. When you're working with the multiplication of two numbers that have the same base, the process simplifies significantly. You don't multiply the bases. Instead, you keep the base the same and simply add the exponents together. For example, if you have am times n, this would result in am plus n. To illustrate the concept of the product of exponents, let's consider the following example. Suppose we have 2 cubed times 2 circumflex 4s. To find the product of these exponents, we can use the rule that states when you multiply two numbers with the same base, you add the exponents. So, for 2 cubed times 2 circumflex 4. First, we add the exponents, 3 plus 4 equals 7 watt. Then, we rewrite the expression with the base, 2, raised to the new exponent, 7, 2 circumflex 7s. Thus, 2 cubed times 2 circumflex, 4 equals sign, 2 circumflex 7, which simplifies to 128 plus. This demonstrates how we combine exponents when multiplying numbers with the same base. Explaining the division rule for same-base numbers. When you divide two numbers that share the same base, the process is simplified by subtracting the exponents from each other. Here's a detailed explanation of how to apply the division rule effectively. If you encounter an expression like a circumflex mim divided by a circumflex nens, you should rewrite this as akes raised to the power of mn's. Exploring the power of a power rule, when you encounter an expression like amn, a simple method to solve it is by multiplying the exponents. This results in amsn, providing you with the new exponent for the base a. Exploring the power of a product property in mathematics, specifically a b n anx bn a n anx b. This rule tells us that when you raise a product to an exponent, the exponent can be applied separately to each of the factors involved. It's a handy tool for simplifying expressions in algebra and higher mathematics. The power of a quotient property is expressed mathematically as follows. abn equals n multiplied by bn, which can also be written as b n equals bn multiplied by n. This demonstrates that when you are raising a quotient to an exponent, you have the ability to apply that exponent separately to both the numerator and the denominator of the fraction.